All right, today is going to be a discussion on playlist 5 and a practice problem. So the beginning of playlist 5 is sort of convergence test recap. Do you want me to go? Okay. First, we have the divergence test, which is sort of like an unofficial test. And it's if the limit of the sequence heads towards 0, then you know that the series converges. But if the limit of this sequence doesn't head limit towards 0, then it diverges. So the requirements for the test are none, and the conclusions you can draw is whether or not it diverges. And for the integral test, the requirements for that one is that the function has to be positive and decreasing. And if the integral of that converges, then the series converges as well. But if the integral diverges, then the series diverges. So whatever the behavior of the integral is going to be the behavior of the series. Then the comparison test, you need another series to compare it to. And sort of the same with the integral test, where if one converges, then the other one converges. If one diverges, then the other one diverges. And sort of the same sort of idea for the limit comparison test as well. So for the ratio test, the requirements you need for that one is to use the, expression. The limit as n approaches infinity is going to be the absolute value of the series plus 1 over the absolute value of just the base function of the series. And from that, depending on what your L, which is the value from that, you can figure out whether it's converging, diverging, or inconclusive. And the specifics of that is if L is less than 1, then the series converges. If it's greater than 1, or if L is infinite, then the series diverges. But if the number that you get is equal to 1, then there's nothing conclusive that you can figure out. So you'd have to use a different test. And then the last convergence test is the alternating series test. And the requirement to use that one is the series has to be alternating and positive and decreasing. And if the value of the series plus 1, both of them have to be positive. The value of the series plus 1 is less than the value of just the first series, or I guess the first number that you plug into it. And if it's limiting towards 0, then you know that it converges. Otherwise, it diverges. So, quick recap. Now, the new information was 9.5.1, which is power series. And in the video, Tom uses a function and he throws like other higher degree polynomials on them, to illustrate that you're using partial sums of a series to approximate a function over a very specific interval. So first you have to figure out that interval, and the higher the degree of the partial sums that you're adding up, because each like term of the sum is almost a series in itself, the higher the degree, the more accurate the approximation of the function, but over a specific interval of the function. And then 9.5.2 is radius of convergence. It's a very similar idea to intervals of convergence, but it's looking at the actual value of the x values for which the partial sums converge. Oh, I didn't say that about the last one. The partial sums also have to converge over that interval. That's what you're looking for. So for the radius of convergence, you're looking at the x values for which the partial sums converge and can accurately approximate a function. All right, and now our praxis problem is find the interval of convergence for the series 3 raised to the n times x raised to the n. All right. Oh, also, did anyone have any questions on everything that I went over?
Could you just remind me one more time the test from 9.5.1? The what was the interval convergence test? Was it?
Intervals of convergence, sort of.
Mm-hmm.
So using partial, you have to use the partial sums of a series over a
Mm-hmm.
specific interval to approximate a function, and those partial sums have to converge. And so the higher the degree of each partial sum that you're adding up, the more accurate it's able to approximate the function over a specific interval.
And how does that exactly differ from the test from 9.5.2?
The test from 9.5.1 is just concerned with the actual interval. With 9.5.2, it's concerned with the actual x values within that interval.
Gotcha. Thank you.
Yeah.
Just wanted to point out something. So when I was doing the web work last night, there were a couple questions. There was a question about the alternating series. A couple questions about alternating series tests.
Yeah.
If you just use the first few terms, you might have like a certain one behavior. But if you think about like how the behavior would be when when n is like 100 or something really really big number, that might show a different behavior. So the question I was doing, so if you just did the first four terms, it looks like the series is going to diverge because n plus 1 is always bigger than n. But then if you start examining it when n is like 100 or like a really really big number, then you'll start seeing a pattern where n plus 1 is actually smaller than n, which is what you need, which is one of the requirements for you to say for converging if it's an alternating series. Just wanted to point that out if anyone ran into that. But yeah, we can start trying to look at this discussion question. So,
do you guys have any questions for me right now? Or you guys do? I can let you guys just work, and I can go back to the main room and come back to you. I just don't want to be hovering over.
Yeah, I think we're okay for now. Thank you, though.
Okay.
Yep.
Bye.
See ya. So the series here is the sum. Is it the sum? Is it how you say it? The sum from n equals 1 to infinity of 3 to the n times x to the n. So if we write out just like a couple of the terms, what I'm getting here is.
Do you want me to write this out?
You like screen share? Like share your screen and like go for it.
Yeah.
Okay, hold on, let me grab my pen. Here it is. Okay, wait, do you want me to screen share?
Yeah. Wait, Alfie, are you ready?
You're muted.
I didn't even know. Yeah, Alex, if you want to do it, you can.
Okay. So
the function is the sum of from n to 1, n equals 1 to infinity. 3 to the n, x to the x to the n.
What is x defined as in this series?
I don't think it is.
So is it virtually the same as? Wait.
X is like a variable. So I guess the series kind of spits out a function.
Okay. Oh,
Yeah,
right.
The series spits out a sequence of functions. Well, I don't know if that's the right terminology, but like basically the series consists of a sequence of functions.
So this is basically just a geometric series, but with x's. But it's like a function.
Like functions, functions.
Yeah, so the first three terms would be 3x plus 9x squared plus 27x to the third. And then it just gets like really, really big numbers. So I'm not sure how we would actually figure out what the integral convergence would be unless we would like graph it or something.
Yeah. Well, to be able to evaluate this, would you just plug in? Are we taking a limit? Are we finding like? Are we evaluating this with like actual?
We can do the ratio test. I think.
Okay.
That'll probably be the easiest.
If we use
You want to do the first terms for the ratio test, or the second two terms for the ratio test?
Or the entire term, or the entire polynomial.
Any two terms, any consecutive terms.
Mm.
So,
Wait,
okay.
is it only just two consecutive terms, or is it
Yeah, it's you're dividing n plus one by n.
Oh yeah.
So it has to be
But
two terms that are next to each other. So I guess you can write limit as n approaches infinity. Of the absolute
for a
value
second, yeah.
of
we're gonna do 9.
so is it 9 times 2 squared?
What? Do you mean
Because
by
it's
that?
Oh no, 9x plus 1 squared. Parentheses x plus 1.
oh okay. Say.
No.
Well, it's
X
like
plus 1 is in
1,
parentheses.
right?
It does not include the
Oh
9.
wait, oh I get what you're saying. My bad.
Uh-huh.
Oh wait, no.
Like that.
Yeah, that should be.
No,
What is
this
it?
Wait, what are you guys saying?
is wrong.
It would just be the terms themselves, because that's like the term coming after 3x, right? Like it'd be like
So
9x
it'd be
squared over-
9x squared, right?
Yeah.
It would be no,
What
it would be 3n
Oh,
plus 1 times x to the n plus 1. You're using the base function.
Oh, okay. Yeah, if you just use a
Oh,
base
you-
function. Okay. Yeah, okay, that makes sense. Yeah, so 3. No, raised to the
power n
n.
plus 1.
Oh, okay. Sorry, I don't have it in.
Equivalent
No
though.
worries.
3 to the power n plus 1 times x to the n plus 1 is the same thing as 9x squared.
Times x plus 1?
No, x to the n plus
oh,
1.
raised to.
Oh, I see what we're doing. Never mind.
There you go.
Okay.
Yeah.
Over 3n times x to the n.
Yeah.
Yeah.
Hi.
I don't know why it took me so long to figure that out.
Yeah. So
And then so you could just
Yeah, isn't that just 9x squared over 3x?
hold on, let me simplify.
I don't know.
And then it would go to 3x. It would be like limit as n approaches infinity is 3x. Which would mean
3
Oh, well, yeah. That doesn't make any sense.
times x n. So it would be 3. It would just be 3x.
mm-hmm.
Wait,
And
this
so
is 3x?
yes, because it would be 3 to the n times 3 times x to the n times x, and then the x to the n, x 3 to the n would cancel, and then it would be just 3 and x left. If you simplify,
yeah, I see. Okay.
yeah.
Wouldn't
And so this would diverge,
the oh yeah. Okay.
but because it's 3x,
Mm-hmm.
Hmm.
But William, you said something about like if you look at only like the first few terms, its behavior can be different from what it actually is later down the line. Do you want to do like?
I think
yeah.
maybe that just
Another one. So, I think we could do just like move the terms then. So it would be
I think we should think
the
about
bot.
wait, how did you guys get to 3x again?
So if you for 3 to the n plus 1, if you simplify that, you can rewrite it as 3 to the n times 3 to the 1. And then same thing for x to the n plus 1. It'll be x to the n times x to the 1.
Oh.
And then you just cancel out the top and the bottom to just get 3x.
Oh, okay.
But yeah, so like I guess that doesn't tell us much. So we can.
Wait.
Okay, yeah, that works. Yeah.
Wouldn't that be the same if it's
That
27
means you would just get
9?
Wait, that would be 9.
yeah, 3x. Okay, yeah.
Sorry, an x plus 1 over 9n